Hello everyone, and thank you for joining the session. I'm Sujith Nair, CEO and co-founder of Beckn Foundation, and along with me is Ravi Prakash, my colleague, who's also the head of architecture and tech ecosystem at Beckn Foundation. And we are going to talk about Beckn, the idea of Beckn Protocol, and how it enables large-scale decentralized digital ecosystems. Now, some of you may have attended Dr. Pramod Verma's session on how India is imagining large-scale, population-scale digital ecosystems with open protocols like Beckn. In case you missed it, please watch it when you can. In this session, we'll talk about Beckn Protocol in particular and talk about the idea, the motivation behind Beckn, what exactly is Beckn Protocol and what it is not, and also talk about how we are seeing the adoption of Beckn Protocol around us. And Ravi will talk about Beckn in detail, explaining the technical architecture and other details, and also showcase very short demonstrations of Beckn in action. So let's begin. Now, if you look at the primary model at play in digital economy today, it hinges on this approach, a platform-centric approach whereby you need a central intermediary to bring consumers and providers onto one central monolithic platform to have any interactions going between them. Both the consumers and the providers need to be on the same platform to discover each other, find a way to trust each other, and participate in order making and fulfillment. Now, this model creates many platforms to exist in silos. In some sectors, there are too few platforms, big ones, and in many sectors, there are several fragmented set of platforms. Now, the consequence of this model is that you have this closed ecosystems with closed loop value creations within this confined to a particular platform. And these platforms where the consumers and providers are interacting is creating this confined storage of value in the form of data, which is actually critical data for both consumers and providers. Now, if I were to take an example of a taxi operator or a hyperlocal delivery agent who's been using a platform for a long period of time, generating order history and reputation and rating for himself or herself, today has no choice to but let go of this critical business credential data while moving from one platform to another and starting from scratch. The platform intermediary is acting almost as an operator, defining the rules of interactions, exerting influence on how the consumers and providers on the platform must interact, and also define the incentive structure between them and for itself. Now, all this is creating some sort of friction for consumers and providers, especially small businesses like the taxi operator or the hyper delivery agent or a small grocery store to do business online. Now, is it possible to reimagine this model? Now, we don't have to look far to look at what could be the possible alternatives. We looked at large-scale, planetary scale, population-scale digital infrastructure like internet, email networks, or our India's own UPI networks. At the heart of its design is this decentralized open network model that drives its adoption at scale. Now, with an open network-centric model, instead of a platform-centric model, we can imagine both the consumers and providers to have choice to be on any platform of their own, to be on different platforms, and yet discover each other, kind of trust each other, and also engage in order making and fulfillment transactions. Now, this can be possible by Beckn, and this is where Beckn becomes significant. Beckn is that lightweight protocol that makes two disparate platforms talk to each other and understand the language of, say, commerce, mobility, healthcare, etc., and create an open network among these platforms participating in such interactions. Now, if I am a consumer buying grocery or looking for a ride online, I could be on any platform of choice. It could even be an instant messenger. It could be a map app or even a basic browser to search for any provider or any platform out there on an open network that is enabled through Beckn Protocol. Now, Beckn is this machine readable language that semantically understands the language of commerce, mobility, and other such sectors, and make platforms come together as an open network to provide this choice to the end consumers and providers. Now, imagine the possibilities as a tech entrepreneur, as a developer, the possibilities with Beckn Protocol in creating large-scale, vibrant digital ecosystems with no center or central intermediary to depend on in the middle. Now, Beckn as a story started off in 2018. The first set of specifications came out in October 2019, focusing on mobility, but then it quickly expanded beyond mobility to cover all areas of commerce and other sector. Today, it is a community-based effort where you have many contributors contributing to the evolution of Beckn to create a much better enriched version of Beckn Protocol across various layers of its design, which Ravi will soon talk about, to kind of create a very robust protocol that can probably look at achieving population scale adoption. Its first live implementation happened in November 2020, and ever since then we have been witnessing many such implementations. One such, and the first of its kind, is the mobility network that got created in the city of Kochi in India. Kochi Open Mobility Network is the world's first decentralized mobility network, which looks at this open network model, which allows consumers to use any app to discover a ride from multiple providers on the network who happen to use their own independent platforms to make their services available. Now, this is just one example. The other example is India's Open Network for Digital Commerce initiative, which is looking at a nationwide implementation of decentralized commerce, focusing on retail, supply chain, and other sectors to bring all sorts of businesses, especially the physical retail stores, whether they're small or big stores, bring them online and enable their discoverability and enable them do business on the network. And the consumers can use several types of buyer apps to kind of get onto the network and discover these sellers, their catalogs, and place orders on. So what you've seen with mobility and commerce is sort of the possibilities that exist with Beckn Protocol, and it kind of opens way for creating many such open networks, not just in India, but across the world. Today, we are seeing traction go beyond the Kochi Open Mobility Network and the Open Network for Digital Commerce, ONDC, and Beckn is being adapted for creating a decentralized healthcare protocol, decentralized skills and employment kind of an ecosystem, all using the underlying Beckn specifications. Now, to talk about Beckn in detail and the technical architecture, I invite Ravi to take you through the rest of the discussions.
Beckn Protocol fundamentally unbundles any consumer-provider interaction that today happens on a single monolithic platforms onto multiple platforms, and unbundles the consumer-provider interaction lifecycle into 4 stages, namely discovery, order, fulfillment, and post-fulfillment, using a set of standard APIs that are asynchronous and independent of each other. In the discovery stage, a consumer declares his intent to purchase a product or service. In the intent, a consumer can either search for an item or a product, browse catalogs, apply filters for rating, for categories, and for modes of payments, etc. As a response, a provider can expose a catalog that matches the consumer's intent. In the order stage, the consumer and the provider progressively build the order by agreeing to the terms of service, the quotations, and the terms of fulfillment and the terms of cancellation. In this stage, a provider can also push dynamic offerings like discounts and promotional add-ons. At the end of this stage, the consumer finally places the order by agreeing to the terms of service, which results in the subsequent confirmation of this order. In the fulfillment stage, a provider fulfills an order by assigning an agent who does the order fulfillment. Okay. Fulfillment could mean different things in different domains. For example, in the retail and logistics sector, it could mean the delivery of a package. In the mobility sector, it could mean a ride taken by the user. In the healthcare sector, it could be a consultation made for a patient by the doctor. During the course of fulfillment, a user can do a live tracking of the fulfillment, view regular status updates, modify an order, or even cancel the order as per the terms of cancellation that was agreed during the order stage. During the post fulfillment stage, a consumer can rate the order or contact support or even provide feedback of an existing order. Beckn Protocol specification is not just a set of open APIs alone. It's composed of 5 layers that allow decentralized interactions between a consumer and a provider. Each of the 4 stages that was discussed earlier can be represented as a set of 10 standard APIs. In the Beckn terminology, we call these APIs actions. As you can see, the discovery API consists of a single API called search. The order stage consists of 3 APIs, select, init, and confirm. The fulfillment stage consists of 4 APIs, that is status, track, update, and cancel. And the post fulfillment stage contains 2 APIs, that is rating and support. Each of these APIs are asynchronous APIs, which means that each of the APIs that we just discussed has a callback, which means search has a callback called onSearch, select has a callback called onSelect, and so on and so forth. Secondly, all of these APIs are asynchronous APIs. Okay. As we had mentioned earlier, search has a callback API called onSearch, select has an callback API called onSelect, and so on and so forth. This was done for 2 reasons. One was to allow the APIs to scale more effectively, and second, this was also done to emulate real world interactions where the response is not always immediate but deferred for later. Beckn Protocol also defines a standard sector agnostic schema that any domain specific data model can be mapped to. Beckn Protocol identifies 4 actors, namely Beckn application platforms or BAPs, Beckn provider platforms, which are BPPs, Beckn gateways or BGs, and a network registry. The next component of these specifications is the transaction mechanism. This consists of asynchronous APIs, which we just discussed earlier, broadcast APIs, single request, single callback APIs, single request, and multi callback APIs. The last component of the specification includes sector specific extensions that are not included in the otherwise generic schema of the Beckn protocol. The most important component of any specification is a strong set of design principles. For Beckn, they are interoperability, optimal ignorance, security, privacy and consent, scalability, reusability, and unification over standardization. The specification must evolve in adherence to the design principles just discussed above. To ensure the spec evolves in a right way, in addition to the design principles, any updates made to the specification must also be supported by a strong community-driven governance model. Beckn Protocol adopts a community-driven governance model. The core working group of Beckn Protocol, which is the maintainer of the Beckn Protocol specification, facilitates the evolution of the specification. It accepts requests and proposals from the open community, applies the design principles that we just discussed above on top of the specification, and decides whether a particular proposal or a feature request can be made part of the specification or can be deferred for later or is irrelevant to the specification. So as you can see, the open community governance model and the design principles create the guide rails that facilitate the smooth evolution of Beckn protocol. Let us now take a look at an illustration of an open network created using Beckn protocol. Every protocol needs a digital infrastructure to support the communication that is made by the APIs that we just discussed earlier. In Beckn protocol, the infrastructure is called an open network. And let us take a look at what a Beckn protocol enabled open network looks like. The bottom layer of the architecture consists of Beckn provider platforms or BPPs. BPPs expose their catalog of services and products and allow orders to be created via a standard API. The top layer consists of Beckn application platforms or BAPs. These BAPs acquire consumers and bundle the services and products that are offered by the various BPPs on the other end and stitch them together to create a rich integrated experience to the end consumer. The middle layer consists of Beckn gateways or BGs. These nodes basically act as routers that route search packets made by BAPs and broadcast them onto multiple BPPs and relay back the responses made by these BPPs back to the BAPs. In addition to such features, the BGs can also offer value-added services like search optimization, map reduce, orchestration, and experience stitching, etc. Given that these are independent platforms talking to each other over an open API, there has to be some mechanism for establishing trust between these two platforms. Okay. For example, a BAP who has placed an order and a BPP who has fulfilled that order, the BAP user might claim that he never received the order. So is there any way to prove that the transaction actually happened between a BAP and the BPP? There has to be some mechanism for establishing that trust. One way to establish that trust is by digitally signing every message that is sent. Every message that is sent on a particular network via Beckn Protocol must be digitally signed by the sender, and that digital signature should be able to be digitally verified by the receiver. To facilitate this digital signing and verification of messages, a public key infrastructure is required. In Beckn, this public key infrastructure is called a network registry. The network registry stores the public keys and endpoints of all trusted participants of a particular network. A participant can prove his trustworthiness by going through certification processes for protocol compliance, schema, security, and industry standards. Furthermore, an open network on Beckn Protocol must rely on additional services that allow it to become more robust, scalable, secure, feature-rich, and future-proof. These additional services could range from payments, credit, open data APIs, rating and reputation ledgers, verifiable credentialing, and online dispute resolution. Finally, networks could also communicate with other networks that have implemented Beckn Protocol. BAPs on one network might be offering their services as BPPs on another network. Similarly, BPPs on a particular network might be consuming their services as BAPs on a separate network. Various configurations or topologies between these networks can be implemented. This is especially useful in the case of retail and logistics sector, where there are retail networks, logistics networks, wholesale networks, and OEM networks that are all working together to deliver a product to the end consumer. In conclusion, Beckn Protocol allows interoperable transactions between application platforms and provider platforms via a standard set of APIs. It also allows for sector interoperability via a standard schema. For example, a patient could book a consultation from a doctor on a healthcare network, book a cab to take him to the consultation, and parallelly also book a food delivery to be made after the consultation, depending upon the recommendations made by the doctor. It also allows for open network policies to be published via a standard machine readable policy schema and APIs. It allows trusted contracts to be established by means of digital signatures. It allows platform discovery via a registry infrastructure, and it also allows packet switching via a gateway infrastructure.
In this session, we will be showcasing two demos that demonstrate the working of Beckn Protocol. The first demo will demonstrate a typical retail order flow between two Beckn-enabled applications. The second demo will involve 4 applications that demonstrate how Beckn-enabled applications, integrated with a blockchain network, can be used to transmit verifiable credentials all the way from a manufacturer to the end consumer. Let us begin with the first demo. On the right, we have a Magento platform with a Beckn-enabled extension acting as a BPP. On the left, we have a typical Beckn-enabled consumer web app acting as a BAP. As you can see, the BPP is a typical grocery seller. Let us now go to the BAP app and begin our search. We then go to our BAP app and log in and set our location where we want our order to be delivered. Now let us go to the search bar and enter the words, cheese and bread, and hit search. Immediately, the BAP fires a Beckn Protocol search request to the BPP through a BG broadcast. As you can see on the right, the BPP has received the search request and has returned an on-search callback containing products that match the search. Let us now select our items and view our cart. As you can see, the BAP fires a Beckn Protocol select call, this time directly to the BPP, and receives an on-select callback from the BPP containing the quote for the selected items. Let us now proceed further and fill in the billing and shipping details. As soon as we save the shipping details, a Beckn Protocol init request is fired from the BAP to the BPP. The BPP then calculates the delivery charges, adds it to the total amount, and returns an order object through the on-init callback to the BAP. If we scroll down to the bottom, we can see the total amount to be paid for the order. Let us now proceed to payment. We select cash on delivery as our method of payment. Finally, we hit confirm. The BAP then fires a Beckn Protocol confirm request containing the final draft of the order to the BPP. The BPP then creates the order and sends it back through an on-confirm callback to the BAP. The BAP consumes the order object and shows the confirmed order on the app with the latest fulfillment status. Let us now go to the BPP's order management page and view our order. Here we see the various orders that have been placed earlier, including the one that we just placed. We view the latest order and see that it indeed contains the same order ID that we see on the BAP. As you can see, the order on the BAP still says pending confirmation. Let us now confirm the order from the BPP. We do this by going to the Ship tab on the order management screen and click on Submit Shipment. Immediately an unsolicited on-status callback is sent to the BAP with the order status is confirmed. We have now entered the fulfillment stage of the order. In this phase, the BPP sends fulfillment updates to the BAP. As you can see, the order now goes through various states of fulfillment like searching for agent, agent assigned, delivery agent en route to pickup, delivery agent at store, order picked up, delivery agent en route to drop, and delivery agent at drop location. Each of these statuses are sent through unsolicited on-status API calls from the BPP to the BAP. Many such fulfillment statuses can be created and commonly agreed upon by the participants of a network. These fulfillment status codes are not prescribed by the protocol and are left to the discretion of the network participants to decide which statuses should be supported by the network. Each of these statuses are sent through unsolicited on-status API calls from the BPP to the BAP. Typically, the last state of the fulfillment is usually order delivered. Finally, on confirmation that the payment has been received, the seller goes to the invoicing page and generates the invoice. This sends a final on-status call to the BAP with the updated payment status as paid. This marks the order as complete. Thank you for watching this demo. Both these apps are open source and can be found on the Beckn Protocol GitHub page. To go to these repositories directly, please scan the QR code shown below. Let us now begin our second demo. This demo involves 3 people. An apple farmer who farms 1,000 units of genuine Shimla apples each month. The grocery retailer purchases 90 units of apples from the farmer, and a typical consumer who wants to buy some apples from the retailer. The farmer uses a Magento-based app that he uses to manage his inventory and orders from retailers. The retailer uses 2 apps. A supply chain app he uses for purchasing apples from the farmer and other manufacturers to restock his inventory, and a Magento-based retailer app that he uses to manage his retail inventory and orders from end consumers. The end consumer uses a typical e-commerce app that he uses to buy products from various retailers. All these apps are Beckn Protocol enabled. Typically in a Beckn enabled network, the platform credentials like their API URLs, public keys, platform ID, etc. are stored on a public key infrastructure in the form of a centralized registry platform to allow digitally signed messages to be transmitted. In this example, the platform credentials are stored on a blockchain. Meaning, instead of a centralized registry owned by a central regulatory authority, blockchain networks can serve as an open and trustless decentralized registry with no concentration risk. The core network is one such blockchain network that stores verifiable credentials for various entities like platforms, businesses, and products. These credentials are immutably stored on the core blockchain nodes. Meaning, once stored, these credentials cannot be changed and can be verified by any authorized entity. In this example, the credential stored on the blockchain is basically a hash of the product details, containing the SKU, its available quantity, and an example certificate called AgMark, issued to the farmer for producing high-quality product. It is then transmitted from the farmer to the retailer and then to the consumer platform through Beckn Protocol APIs. Any Beckn-enabled platform can now verify these credentials before placing an order for that product. Let us now begin our demo. As we can see, we have a typical Beckn-enabled supply chain app on the left acting as a BAP. On the right, we have a Beckn-enabled Magento seller app acting as a manufacturer BPP. In this demo, we will show how platforms can digitally verify the credentials and availability to promise of the products sold to their users on a Beckn-enabled network. Let us now upload a fresh batch of apples to the farmer's catalog. Once uploaded, the BPP fires an item.create remote procedure call to the cord network. In cord, blocks are mined approximately every 6 seconds. Let us now shift our view to the cord blockchain and take a look at the transactions added. As you can see on the cord blockchain viewer, the item.create event has been executed when the chain received the product. The hash of the product is now stored on the chain, creating an immutable verifiable credential. Let us now shift our view back to the BAP and run a search for apples. When we hit search, it fetches the apples from the farmer's BPP using the usual Beckn Protocol search broadcast through the BG. As you can see, all products with verifiable credentials have a green verified icon. Let us now quickly add a few apples to our cart, provide our billing and fulfillment details and place an order. Upon clicking confirm, the BAP fires an order.confirm remote procedure call to the cord network. This call executes a smart contract on the chain nodes that verify from the previous blockchain transactions if the farmer is truly the owner of these AgMark certified apples. This is also called verifying availability to promise, or ATP. Once the ATP is verified, the supply chain BAP fires a Beckn Protocol confirm API call to the supply chain BPP. The supply chain BPP then fires an item.delegate call to the cord network that records a reservation of the ordered quantity of apples to the retailer on the blockchain. Once done, the supply chain BPP sends an on-confirm callback to the BAP with the status as confirmation pending. The farmer now creates the shipment. The BPP then fires an unsolicited on-status call to the BAP with the order status is confirmed. The BAP sees that the order is confirmed and can now add the SKU received from the BPP to his own catalog. Let us now shift our view from a supply chain context to a retail context. We now open the retail BPP's product catalog and add the same apples that we purchased from the farmer as a supply chain BAP. Let us add the same product, that is, AgMark certified Shimla apples with the same SKU ID that we got from the supply chain BPP. This time we will try and add more apples than we bought. Let us try and add 200 apples to the catalog with the same SKU ID. As you can see, the seller console returns an error saying, unauthorized catalog update. This is because, before the addition, the retail BPP fired an item.add call to the cord network. The chain nodes executed a contract that verified if the retail BPP was truly the owner of 200 apples. Since he was not, the network returned an error. Let us now add the correct quantity of apples purchased from the supply chain BPP. We now add 90 units to the catalog, and it gets successfully added. Now let us go to the retail BAP and search for apples. The search completes with the same verified icon visible on the search results. We now add these apples to our cart and get the quote. Once done, we add our billing and shipping details to get the final amount that is payable. We now proceed to payment. We select the cash on delivery option and then confirm our order. Like before, the BAP first confirms the product's availability to promise from the cord network using the same order.confirm call. Once the ATP is verified, the BAP fires the Beckn Protocol confirm API call to the retail BPP. The retail BPP then calls an item.delegate call to the cord network that records the reservation of a dozen apples for the consumer on the blockchain. The BPP then fires an on-confirm API callback to the BAP that renders the order on its app. As usual, the BPP fires an unsolicited on-status callback to the BAP when the retailer generates the shipment, thus confirming the order. As you can see, we have successfully managed to transmit a verifiable credential across 2 cascaded networks using Beckn Protocol and ensured its immutability using blockchain technology. In this demo, we have shown that Beckn Protocol can be layered on other technologies like blockchain to provide value-added services like decentralized registries, provenance tracking, and availability to promise across independent platforms that ultimately boost the consumer's trust on products and services that are offered on an open network marketplace. Thank you for watching this demo. All these applications are open source and can be found on the Beckn Protocol GitHub page. To visit these repositories directly, please scan the QR code shown here. To visit the Cord Blockchain Viewer, visit apps.cord.network.
Do join the growing community of Beckn Protocol. Visit us at becknprotocol.io. Participate in the ongoing discussions on GitHub. Looking forward to your contributions.